Right, this problem will complete the square, and the first thing you have to do is make sure that the squared term has a coefficient of 1. So for this problem, we'll take the 3 and we'll pull it out from all three terms. The only thing is it doesn't exactly divide by 23, so we'll just put 23 over 3. The next thing you want to do is group the first two terms, leave a space, and sort of pull away or space apart that C value that's left. So what that will look like is t squared plus 6t. I'm going to leave a space, and I'll put minus 23 over 3. Next step is to determine that half of b squared magic number that you have to come up with to actually complete the square. It's going to live here. So what we'll do for that is take half of positive 6, which is 3, and we square 3, we get 9. Remember, we have to add 9 on the inside and subtract 9 on the outside. Again, we're working in one large quantity. And then after that, you'll factor your square, the perfect square quantity that we came up with, the one that lives here. So what that turns into is t plus 3 and t plus 3. Again, that's going to be the same whenever you took the half of b. That's what ends up in those quantities for the perfect square, so that it can be expressed as t plus 3 quantity squared. The other part, this negative 23 over 3 minus 9, when you subtract those, negative 23 over 3, you have to make it 27 over 3 to get a common denominator, and that'll leave you with minus 50 over 3. And then when we distribute the 3 back through to both of those areas, it just sits in front of the t plus 3 squared, and then it becomes minus 50. And that is the factored form after completing the square. In Wiley, there's an alternate way to this that sometimes avoids fractions. I just wanted to show that to you in case you use the help. But it's especially from what's used on Wiley. It takes the 3t squared plus 18t minus 23, and it only factors the 3 from the first two terms, because those are the two that had the common factor of 3. And then after it does that, it goes through the same process of half of 6, just 3, squares it, and it does add that quantity, but it does not subtract the same 9 from the outside. So that's what we cannot do. It will subtract something, but it has to come from what you would get if you brought that 3 back inside to that 9. So instead of subtracting 9 at that point, it will actually do a subtraction of 27, and again, that just comes from the 3 that's been pulled outside times the 9 that we got from finding that magic number. So when you do that and clean it up, you do actually get 3t plus 3 squared and subtract 50 whenever you get that quantity. So it eliminates the fraction aspect on this problem, and you end up with the same answer.